Hello everyone. Now, we will continue with the approach 4. Next in approach 4 is the fabric assurance by simple testing. In short, it is called FAST. So, FAST is developed by CSIRO Australia. It has got again 3 modules and a test method FAST 4. So, compression module, bending, extension and the dimensional stability. So, this also should be incorporated in the course. I will not go in depth. Okay. First one, which measures the fabric thickness and surface thickness of fabric, it is very simple one. Only thing is that we have to have support fabric and certain pressure foot, and the difference between FAST system and covered system, continuous curve we get and both loading direction and unloading direction graph, and from there we can analyze. But in FAST system it is only unidirectional and that too in discrete mode. So, here in compression system we can measure the fabric thickness at only 2 and 3 points. Similarly, bending is again it is very simple, it is similar to the normal stiffness tester. This is the normal stiffness tester, okay, but with a software attachment we can get the data from all these modules, first 1, 2, 3, 4, and finally we can plot the FAST chart. I will discuss. Similarly, extension principle, here we have discrete value at different load like 5 gram force per centimeter, 20 and 100 gram force per centimeter, we can get the extension value. This is the extension value. Similarly, here we can measure the shear test also using the biased extension. This is the biased extension, it is not in the direction of either warp or weft. We can get the at different biased extension, typically it is 45 degree bias angle is used. And one most important aspect of FAST tester is that its interpretation, the FAST control chart or FAST fingerprints. So, after testing, as I have mentioned, this type of FAST control chart is generated for a fabric and the shaded zones are problematic zone, and in one diagram we get all the characteristics like relaxation shrinkage, hygral expansion, formability, extensibility, bending rigidity, shear rigidity, thickness, surface thickness, released surface thickness, all these characteristics we will get. And when this curves coming in this zone, shaded zone, that means it gives indication that there may be some problem, one must take care of this problem. Okay. In the functional testing characteristics, now we will discuss the transmission characteristics. Transmission in the form of air transmission, in the form of moisture, in liquid form, in vapor form, and heat transmission. So, air permeability we are not going to discuss here, because air permeability is normally taught in the course in detail, and my submission is that we do not give in, we should not give in depth in one aspect only. Although air permeability is important, in addition to that air permeability, other parameters are important like liquid moisture transmission, vapor transmission, thermal transmission. This also should be incorporated in the course curriculum. liquid transmission, it takes place in two stages. First stage is wetting and second stage is the wicking, that is actual transmission. The transmission of liquid takes place only if it is wetted. Without wetting, the transmission will not take place. During wetting stage, what happens? The liquid penetrates into the pores, and once it is penetrated into the pores, then there will be capillary pressure generated and that will drag the liquid. So, these are the equations. Wetting follows the Young's equation, and wicking it follows this equation. Okay, it is a Laplace equation, where the theta is the contact angle, this is the surface tension between liquid and vapor, and R c is the radius of capillary. So, lower radius means higher capillary pressure. So, that it follows the Laplace equation. So, liquid transmission it takes place, it is known as the wicking. So, wicking we can measure. So, there are typically three types of wicking we can study, that is transplanar or transverse wicking, in plane wicking and vertical or longitudinal wicking. So, these are the three types of wicking, that is transplanar wicking, which actually from one surface of fabric to other surface it is getting transmitted. Then it is a in plane wicking, the liquid is transmitted along the plane. Another is the vertical wicking, it is against the gravity, it is being lifted using the capillary pressure. So, this is the transverse wicking system, where one sintered plate, perforated plate is used over which the fabric is being placed. This is the water source, and depending on the water uptake, water movement, this capillary, this meniscus will move from right to left, and this volume, from this we can measure the volume of liquid transmitted per unit time. So, this is the animation. So, you must have seen that we can incorporate animation in almost all the methods of measurement. Now, this is the process. Here putting the fabric, and here it is a sintered glass plate. So, once the fabric is being put and we are putting one plate, some weight is, so that the proper contact is there. Now, the water is getting transmitted, okay, and here the meniscus is moving from that, and from there we can calculate the amount of water is being transmitted through time with the reference to time. Similarly, the vertical wicking also we can the amount of water or the height of water we can measure with the time. The moisture vapor transmission we can measure by different methods. Evaporative disk method we can discuss, upright cup method we can discuss, inverted cup method, desiccant inverted cup method, okay, microclimate simulator, moisture vapor transmission cell, dynamic moisture permeable cell. So, there are many methods of measurement. So, depending on our syllabus, on our time availability, we can discuss few of them. Okay. Here I will discuss couple of these test methods. So, evaporative disc method, here the cup is filled with, partially filled with water, okay, and the fabric is actually it is covered with the fabric specimen, and it is kept in a standard environment, and water is being transmitted, vapor is being transmitted through the fabric, and mass of the total assembly initially it is tested, and after certain times, after one day we test. So, and the difference in mass indicates the moisture vapor is getting transmitted through the fabric. So, this is the water vapor permeability, that is 24 into m, m is the mass is lost, okay, through the fabric, and T is the time in hour, and if it is we want to measure per day multiplied by 24, and A is the area of the specimen. Similarly, upright cup method is exactly similar to this evaporative disc method. It works, it is as per the BS standard, here it is as per the ASTM standard. Okay. The measurement method is almost same, and another method is the inverted cup method, which is used for the waterproof type fabric, where the hydrophobic PTFE membrane is used to seal the mouth of the cup to prevent wetting of the specimen. Okay. And so, first cup is there, then hydrophobic PTFE membrane, which is breathable, which has through which moisture can pass through, but water will not pass through, and over that the test specimen is placed, and then it is actually inverted, and mainly it is used for water proof fabric, but rest calculation is as we have discussed earlier, it is same as that. And microclimate simulator is also one method, where this is the mimic skin, and here is the fabric specimen, in between you have microclimate. We can measure the humidity and temperature of this microclimate, and if we see, this is the water source, and from there water vapor will move, and here is the air is blowing. So, from there, depending on the fabric type, we can calculate the condition of the microclimate. Okay. This also shows the moisture vapor transmission characteristics of fabric. Now, as far as thermal transmission is concerned, the main problem of thermal transmission measurement. So, we can measure the moisture vapor, air or water transmission by controlling the direction of flow. Like water flow we can measure by through a pipe, because it is unidirectional, that we can control the direction, even air or moisture. But problem of thermal transmission measurement is that we cannot control the direction. So, for that, to eliminate this complexity, we have to use two techniques. One is comparing the unknown sample with the standard known sample, that is comparing the resistance, thermal resistance. Another is to reduce the heat loss to other directions. These are the two, and this second approach is used for guarded hot plate, and this is used, this technique is used in TOG meter. Now, in TOG meter there are two types of TOG meters one can study, two plate TOG meter and single plate TOG meter. In two plate TOG meter, the bottom plate, which is standard bottom plate of known resistance, and fabric specimen resistance is unknown, we have to measure, and another top plate is placed just to keep the fabrics in contact, proper contact. Now, heat is flowing from bottom through the standard plate, bottom plate, and T1, T2, T3 are the temperatures at different junction points, and as per standard formula we know that the resistance of a plate parallel, that series plates in series, the resistance of that plate divided by the difference in temperature between the plate is always constant. So, using that concept we can calculate the resistance of fabric knowing the temperature, measuring the temperature at different point. R standard is known. Similarly, we can use for this is for calculation for 2 plate torque meter, and for single plate torque meter if we do not want to use the top plate due to the reason of it may compress the fabric, we can use single plate eliminating the top plate by measuring the temperature of air at certain point height. Here the problem is that air temperature is also included, air insulation is also included here. So, for that we have to carry out one additional testing, that is called bare plate testing we have to carry out, and this is the technique. So, T3 is the temperature of the air. So, R first without any fabric bare plate testing is done to calculate the resistance of air, and then resistance of specimen can calculate by using this formula, and where air resistance is deducted. So, this total resistance is including air, and when we deduct air resistance we will get the resistance of the sample, but the formula the concepts are exactly same. Next is the guarded hot plate. As I have mentioned here, we actually we try to guard the, we try to direct the flow of the heat. So, here we will see we have test plate, this is the insulating material, and one is guard plate. Okay. Now, here it is a top view, and if you see the side view, this is the test plate similar to this, these are the insulator, and here this is the guard ring, another plate which is called it is a bottom plate. Now, if we use only test plate, then the heat will flow in all the direction, but once the guard plate and bottom plate is used and keeping the temperature same, so there is no temperature gradient. So, that means heat will not flow sideway or even bottom way, only heat will flow at the top direction, and where we are placing fabric over that, and the total heat will flow through the fabric, and that heat flow we will measure here. Let us try to see here. Now, this is the animation where we are using only the test plate and fabric is placed on that, test plate is connected with the heater, electric connection, it is basically heater, it is connected with the electric power. Now, once it is heated, the heat is flowing in all the direction. So, we cannot measure the actual heat flow through the fabric, but in guard plate approach is that test plate is there, here it is a side view, top view, then we are placing the guard ring, this is guard ring we are placing, and bottom plate we are placed, fabric is placed over that, and then all these plates are heated independently, and we can see from the test plate the heat is flowing through the fabric only. Okay. And the for calculation we use the power required by only the test plate. The guard plate and bottom plate plates are heated at the same temperature just to prevent the heat flow in other direction, and using this formula, that is the total power required by the test plate divided by the area and divided by the temperature difference, that is watt per square meter per degree Celsius, it is the transmittance of the fabric, thermal transmittance of the fabric, that is measured. So, this is the formula we can use. Now, the last segment we have reached. So, in addition to the normal testing, so guard plate, that guarded hot plate and the TOG meter, they test at normal temperature, thermal transmission at normal temperature, normal body temperature. But for extreme heat and flame protection we have many other testings. So, these are the different testing: radiant heat exposure test, flame exposure test with horizontal orientation of fabric or vertical orientation of fabric, hot surface contact exposure test, steam exposure test, hot water splash exposure test, hot water immersion test, flame exposure test. There are different tests. So, here I will discuss only couple of tests. One is flame exposure test. Here flame source is there, A is gas burner flame source, B is fabric specimen, C is the specimen support frame, and D is the skin simulator. This skin simulator is connected with the computer, we get the data. So, we can analyze the data, flame exposure test. Similarly, radiant heat exposure test, this is the radiant heat source A, B is the fabric specimen, and C is again the skin simulator. This gets data. From here we can calculate many parameters like second degree burn or thermal transmission characteristics we can measure. So, that instrument can set to different standards. So, these are the few examples, but we can test many other parameters, and as I have mentioned that different types of technical textile testing like geotextile, composite should be incorporated, and there is no end basically, and depending on our course, even I will suggest we can have more than one course. One is normal testing of textile, another is the for high performance and technical textile testing. So, these are some guidelines. So, I will stop here. Thank you.